Hello, welcome back. This is the second video recording from the lesson of IM1 week 2. So you have just finished watching mashup videos on linear inequalities, and now we're going to get started on writing some notes that goes with what we've just learned from the video. So when we're talking about linear inequality, we're really talking about two variable inequalities. So that's x variable and y variable. And it's going to be on the coordinate plane, just like a line that's on the coordinate plane. So when you think about inequality, think of it as two different things that is added together. So you have to think of it as graphing a line plus shading a region. And we know how to graph a line. There is a slight variation on this, but we are going to talk about that. So when we're talking about graphing a line, it can be greater than or less than. And that's going to have dashed line. Contrast, if you have greater than or equal to or less than or equal to, you're going to have solid line. And the video explained why that is so. See this little line underneath, that is a shorthand for equals. So you have greater than and equals, or less than and equals. That's what it means. Now when we are talking about shading a region, we have two different things to consider. Y can be greater than mx plus b, or y can be greater than or equal to mx plus b. If that is the case, if y is greater than or greater than equal to, then we need to shade above. Shade above the line, and if y is less than mx plus b, or y is less than or equal to mx plus b, then we can shade below. Okay? Alright, so to demonstrate this, let's go through some examples first. So I am going to go through example 1. Y is greater than negative 1/3 x minus 1. So to do this, we are going to start by drawing our coordinate plane. And now, when we're graphing a line, we need to figure out the two things. We need to figure out the slope and the y-intercept. This is the y-intercept. And this negative 1/3 is the slope. Slope tells you the rise over run. So we always start with the y-intercept of negative 1. Negative 1 is here. Put a plot point there. Then from here, the slope is negative 1/3. So the top number is up and down number. Bottom number is right and left number. Top number tells me it's negative 1. That means instead of going up by 1, I am going to go down by 1. And then to the right by 3. And then put a point there. Down by 1, to the right by 3. And then so on and so forth. Just continue those lines. Now that we plotted the points, now we have to consider, now is this going to be a dashed line or solid line? If I see a greater than, that means it's not equal to, is not part of the solution. That means we have to use dashed line. So I am going to draw my dashed or dotted line like so. I should really use a ruler. Now I need to be going to consider the shading. Okay, the shading. Am I going to shade above or below? So let's think about it logically. The first thing you should do is try to read this out loud. Okay, read this inequality. So when we read it, says y is greater than negative 1/3 x minus 1. That's what the inequality is read as. So y is greater than, y is the vertical values. Okay, y is the vertical values are bigger than, you can think of this as the line. Okay, so y is bigger than the line. Where is the y value bigger than the line? Is it going to be above or below? Because it says y is bigger or greater, it's going to, the bigger numbers for y is more positive, is going to be up that direction, it's going to be up there. Okay, all right, so then let's try another. Okay, once we have shaded, it's always a good idea to check to see if my shading is correct. Okay, assuming that your line is correct, now we have to pick a point where we think it is part of the solution. Okay, so according to this shading, okay, then I can say that probably the easy point will be 0, 0. That's just really easy to substitute it in. So it's always a good idea to choose that if it is part of the solution. If it is not, then I might choose some other point. But since 0, 0 is part of the solution that I think it is, then I am going to choose 0, 0. And I am going to substitute that in and see if it comes out with true statement or false statement. Now, if 0, 0, and assume that it is part of the solution, is part of the solution for the shaded region, that means when we substitute it in, it should come out as true statement, because we said that this is part of the solution. So let's try that. So substituting back into the original inequality, 0, instead of y, I'm going to put 0 from here, is greater than negative 1/3. And instead of x, I am going to put 0, is minus 1. Negative 1/3 times 0 is just 0, minus 1 is just minus 1. Is this true? Is 0 greater than negative 1? Yes, this is true. So we expected this to come out as true because we said it was part of the solution, and it did come out as true. So now I know for sure my solution is correct. My shaded region is correct. Okay, let's go on to example 2. Again, let's start by drawing our coordinate plane. And again, we're going to start with the y-intercept of positive 3. And then from here, the slope of 5 over 2. That means 5 is the up and down number, and 2 is the horizontal number. So go up by 2, 5, 1, 2, 3, 4, 5, and to the right by 2. Or you can go, alternatively, go down by 5, and to the left by 2. And then draw a line there. Now, is this going to be a solid line or dashed line? Well, this inequality less than or equal to is over here. Okay, equal to is part of the solution. So this is going to be a solid line. Okay, so solid line. Well, this was dashed line. Okay, all right. Then now we need to think about which side of the line are we going to shade. Are we going to shade below the line, or are we going to shade above the line? Okay, if I look at the inequality, y value, let's use logic, y value, that's the vertical value, is less than or equal to the line. Less than or equal to means it's smaller. We're looking for a region that is smaller in value in vertical values. So smaller than the line, this is the line, and above will be greater, below will be smaller, and that's what we want. It's less than. So we're going to shade in the less than section. Okay. All right, so then Okay, so at this point, probably the trickiest part is figuring out which side to shade. So we're going to go through some quick examples. I think everybody's good with graphing a line, and if you're still not sure, you should be coming to see me during study hall. Okay, so as far as shading up and down, above or below the line, I am just going to go through a quick exercise. Okay, I have 4 examples. I have already drawn the lines, and let's see which side we should be shading from here. Okay, so if I have y is greater than 2x minus 3, y value, the vertical values are bigger than the line. That's what it says. Y values are bigger than the line. Which is bigger? Is it above or below? It's always going to be above, because the higher up you go, the y values are getting bigger. So we're going to shade above the line. Okay, what about the next problem? Okay, y is less than positive a third plus x. Actually, this should be a negative. I forgot to put the negative sign there. Okay, negative a third x plus 1. So if that is the case, then y is less than. That means y is smaller than the line. Y is smaller than that line. When is y smaller than the line? It's below the line. Okay, then what about y is less than 1? Y is less than 1. Okay, y is equal to 1 is the horizontal line. And y is less than 1. If y is here, then y is 0. Is that less than 1? Yeah. If y is over here, it could be something like y is 5. Is 5 less than 1? No, that's not true. So this is untrue, but this is true. Or you can think of it as, is y value less than 1? If this is less than, that means smaller than, so it's going to be below. So we can shading below. And this time x is greater than or equal to 3. Now if I was to graph x equals 3, this will be right here. It's going through 3 and it's a vertical line. Now we need to be considering, is it to the right or to the left? This is not above and below the line. This time it's above, to the right or to the left. And we have to consider, if you have x to be, say, 5, is that 5 greater than 3? Yeah, this is true. What about if x was 1? Is 1 greater than 3? No, that's not true. So we know that it has to be the right-hand side. And that's how you know which side to shade. Okay, so here is the worked out solution to the practice problems. I hope you got this. If you need any help, please come see me during study hall. Okay, thank you for watching. Take care.